in Google Classroom, you want to open up your lab. Your assignment today is the bacteria lab. You guys want to open up that worksheet here. I'll be presenting here in just a second.
Okay, now I'm in Mrs. Zipse's room.
Some lockers.
She's talking to her students right
and then
now.
yesterday with my afternoon classes, we did a janitor's door handle, Mrs. Eiffel's keyboard, a toilet seat, the inside of my mask, underneath my Apple Watch, the surface of my phone. Apparently they want to see how dirty I am. Underneath my shoe, we did do Mr. Kohler's brick that he licks. So that was already taken care of. We did
So basically what's happening right now is we're exploring what type of microhabitats bacteria like to live on. And Mrs. Zipse and Mr. Lang and Mrs. Slutz, so it's great teachers, have been going around swabbing various areas of the building. So we're going to go with them as they swab some areas today.
Over there. All right, turn to the right.
Let's go this way.
You guys want to test the sink, huh? All right, so we're going to walk on in. All right, so we're going to go down into the drain of the sink here. And then we're going to rub this onto the nutrient agar.
This seems really unsanitary to do during a global pandemic. And like the stuff in like one of the handle stuff like a broom or mop.
Ollie.
A handle of a broom or mop?
Yeah, handle of a broom or a mop.
Let's
go. Let's go find that here. All right, so we're heading down the hallway here, following Mr. Hames.
Smile, you guys are on YouTube.
All right.
Are we going that way?
I guess, yeah. We're
Okay.
gonna go down the hallway that leads back to the cafeteria.
Here, you hold that.
Okay.
Mr. Lang, you narrate. I'm gonna swab some guys, just because we used to do this lab in 8th grade. Let's get a good look. There it is. Sterile swab. These come sterile, okay? Let's get in there.
See how gross you guys are at lunchtime.
Is that a raw, like, ramen noodle?
It might be. That's good stuff.
Did you just do it in the middle on yours?
Yeah.
Okay. Trick is here, when we have the students do this, guys, we tell them not to push too hard because they can tear this gel. So it really doesn't take much effort to get the bacteria into the agar if there's any on the swab in the first place. All right, we're good.
Rifle now. And then Hunter, you're gonna figure out where you want to swab in your mom's office. All right.
Good morning.
Good morning. I have your daughter anymore, but if you notice that there are clean pens and used pens. The used pens. Do you really test her that she actually cleans the clean ones?
Which one? Are these the clean ones?
Those are the clean ones.
And these are the there's only one dirty one today?
Well, yeah.
There's more used ones over there.
We'll go here. We'll go down this way. So
Okay,
just slide
coming around.
that on down. We're going to use these used pens right here. So we'll just kind of get down in there on the part that they touch and rub and
Get the little clicky part too.
Little
I don't know what
clicky
that's
part?
called.
The annoying part.
I love clicking pens. It's very
All right.
therapeutic for me.
so we're going to put that onto the agar here. Okay, just right in the middle.
Hey, Mrs. Eiffel.
Hi!
Did I hear Mrs. Zipse came down and swabbed some stuff for you?
She got my keyboard.
Your keyboard? Is that something you clean regularly or?
Well, it's a pretty new keyboard, so we'll see.
Okay.
So this one is the used main office pens is what we're going to
You
put
would be
that
the only
as.
one to touch it, right? Okay.
So I would say that it was dry. It was high traffic. Smooth.
What have you swabbed so far, Mrs. Zipse?
We've swabbed the water dispenser in
Okay.
the teacher's lounge
Uh-huh.
and the library, the graphic novel library books.
Ooh, cool. Where are we heading now?
We are gonna see if we can get into either the music room or the band room for instruments.
Okay, I'm gonna follow. Is that okay?
Sure.
Woo!
All right,
Okay.
We're gonna do the trumpet.
Mr. Mertens is gonna let us swab the trumpet. It's gonna be awesome.
Awesome, thank you.
There you go.
Ba, ba, ba.
All right, let's take a temperature.
Oopsies.
Definitely gonna get where he uses the fingers, right? Making sure we get it good. And then straight line onto the auger. Oh, tearing it.
I like your strategy of the straight line. That's interesting.
Incubator. So it's gonna keep a pretty consistent environment for the bacteria. It's 79.9 degrees right now. It's been fluctuating between 78 and 80 degrees Fahrenheit. Why is it in Fahrenheit? What is that? I also kind of forgot to tell you about this one, but we do have a control in there. So this one is sterile. We didn't swab it with anything, so theoretically, there should be no bacteria that grows on it at all. We're gonna put our other 4 second hour Petri dishes in there, and we're gonna close it.
All right, what I have here are 2 of the Petri dishes from Mrs. Zipse's incubator after 7 days. This is what the Petri dish that was swabbed on the front door handle of the middle school looks like. I'll let you take that in for a minute. And I have one other one that I just grabbed at random, and this is what it looks like after 7 days of incubation of a vending machine in the teacher's lounge. Pretty gross. Now what these teachers are trying to do here is to show that bacteria, a very common single-celled organism that's been around a lot longer than you or me, can live on surfaces that are very close to us, surfaces such as keyboards, surfaces such as drinking fountains, or door handles, or tabletops, or desk areas, or how about our smartphone? There are bacteria there, single-celled organisms that you or I cannot detect with the naked eye. So what are bacteria? Well, I kind of already said they're single-celled organisms. They're extraordinarily tiny, but they're very successful. They can reproduce on their own and very quickly. So bacteria do this reproduction process called binary fission, which is an asexual reproduction process. It means one bacteria can become 2, 2 can become 4, 4 can become 8, and very quickly you have what's called a whole colony of bacteria living in a single space. So what you're seeing here is not just a single bacteria, but tons of bacteria colonizing in one space. Now, the number of bacteria in the world is not exactly known, but it's estimated that there are so many that there are 5 million trillion bacteria living in our world. Now, if you're wondering, that's a 5 with 30 zeros after it. So bacteria are extremely successful in that there are many of them, and we have no idea they're there. It's like this own gigantic world that kind of flies under the radar, just beneath what our senses can detect. In fact, there are more bacteria on the Earth than there are stars in the universe. Now, bacteria are nothing new. They've been around for a long time. We estimate that bacteria have been around for 3.5 billion years. However, we didn't even know they existed as humans until 1674, when a Dutch scientist named Antony van Leeuwenhoek discovered them on one of the first invented microscopes. Today, bacteria are known to live pretty much everywhere. They live in the ocean, they live in the soil, they live on rocks, and of course, as we've seen from this lab, they live on common surfaces that are around you and I and our habitat. In fact, a regular desktop like this one, or of that in an office area, can have up to 400 times more bacteria than something we perceive as really dirty, like a toilet seat. It's shocking to think of that, but we tell our students, think how often the bathrooms in this building are cleaned. They're cleaned every day. But unless I'm intentional about it, I may forget to wipe down the surfaces of my desk or my keyboard. Think about this, students. When's the last time you cleaned your smartphone? But the truth is, not all bacteria are bad. In fact, most of them are harmless. Very select few are harmful. Now, not to freak you out, but there is no escaping bacteria. Your body is filled with bacteria inside of you, and there is bacteria all over the surface of your skin right now. No matter how much you bathe, no matter how much you clean, no matter how healthy you eat, bacteria are thriving in and on you. I'll put it in perspective for you. If you took all of the bacteria that was on your body and in your body right now, it would weigh a collective 4 pounds of your body weight. That's enough to fill something like a soup can. But really, most of this bacteria, we need it. It's good for us. The bacteria in your gut and your mouth helps you break down and digest food. The bacteria on your skin, while sometimes can cause problems, most of the time it helps clean and heal your skin on the surface. But there are bacteria that are harmful. A common example is if you've ever had strep throat. This is caused by a bacterial infection on the back of your throat that's very contagious and would need to be treated with antibiotics. Tuberculosis is another very severe bacterial infection that infects the respiratory tract, bacteria actually living in the lungs that you would need to get out of there. Salmonella or E. coli, maybe you've heard of food recalls at the grocery store where they have to recall food because they're contaminated with this harmful bacteria that would make you sick. But really, bacteria at large are harmless and extremely important to the ecosystem. Now, the last thing I want to point out, and what's really cool about bacteria, is that they are extremely resilient and can adapt to survive in new conditions all of the time. There are bacteria that can live in extremely hot places, extremely cold places. That's because they have the ability to mutate and reproduce and become tougher over time. What that means is they can change their DNA when they reproduce and develop resistances to new conditions. An example of this is they can become resistant to antibiotics, which is kind of concerning in that you take antibiotics to get rid of harmful bacteria in the body. If you have a bacterial infection like strep throat, which I mentioned earlier, you take an antibiotic to help heal and get rid of and kill that bacteria that's causing the strep throat. That's how you get better. But sometimes bacteria can learn to become resistant to these antibiotics by mutating, reproducing, and becoming tougher over time. In fact, one of my favorite videos done by Harvard Medical School, you can find it on YouTube, shows where they made a large petri dish and layered it with different levels of antibiotics. What they found is bacteria species could adapt and evolve over time to become more resistant to really high dosages of antibiotics. There is a distinct difference between viruses and bacteria. While you can get sick from both, but viruses can't live on their own. They're not quite as resilient as bacteria are. Bacteria can live on all kinds of surfaces, but the only way that a virus is going to be able to survive is if it can get inside a host. Then it starts to reproduce using the cells of that organism. So viruses are very parasitic in nature, where bacteria can live very independently. All in all, I hope that this shows you that there are several types of organisms that we take for granted because they are not even there, but there are many more bacteria in the world than you or me, and they're a lot closer to us than you even might realize. I'm going to finish this by showing the results of some of those places that you heard Mrs. Zipse and Mr. Lang swabbing at the beginning of this video. Thanks for watching, guys. Hope you have a great day.